Cool. Thank you, guys. Thanks for the opportunity to speak. I'm Arun. I'm a security researcher with Forescout. And yeah, so every time you see a flat network, you ask this question, right? Do you even segment your IoT network, bro? So this will be a brief overview of my talk. I'll talk about IoT in the enterprise. I'll give you some background on network segmentation and describe the problem. And we'll do a case study of healthcare networks, and we'll conclude this talk. So, believe it or not, 1 in 5 devices you see in the modern enterprise is now an IoT device. And this is just the average. There are many industries where it's 1 in 3 devices. So, what are they? So, you see things like these IP cameras, you see VoIP phones in the meeting rooms, you see physical access control systems like the pad swiping mechanism, which lets you into the office. And if you're a hospital network, you'll encounter things like patient monitors and X-ray machines, and the list goes on and on, right? So this is a large pool of devices to attack. And interestingly, these devices live alongside IT devices in production. And we know these devices are making headlines in all the wrong ways, right? So you remember the incident from a couple of years ago where Vegas casino was hacked through its smart fish tank thermometer. So attackers moved laterally through the network to a database, stole data from a high roller database that the casino was maintaining and exfiltrated it through the fish tank thermometer. So that was a crazy incident. And you see other instances where the IoT device itself is the end target, something like a hospital network in the US getting infected with some ransomware, right? So what makes enterprises vulnerable to such attacks? So our hypothesis is that in a majority of cases, it's due to bad IoT network segmentation hygiene. So from the perspective of the attacker, network looks something like this tasty nugget right here with a crunchy exterior of security controls. And once you get inside the network, it's pretty much a treat. So it's kind of a GUI center type of a network design. And in most organizations, the IoT device management process is not as mature as the traditional IT, like a Windows machine that the corporation owns, right? And the other characteristic is that new devices are getting connected to these networks, often without the knowledge of the admins themselves or authorization. So this is another issue. So let's step back and look at the basics of network segmentation. So what is it really? So network segmentation is like a process of splitting a computer network into subnetworks. So something like the slices you see in this pie, each slice has its distinct constitution, which is separate from the next slice. And in terms of networking, you achieve this with a combination of methods at different layers of the networking stack, right? So at layer 2, you have VLANs, which are a common way to limit the broadcast domain. And then you have layer 3 firewalls, ACL, subnetting, and layer 4 and higher layers, right? So usually segmentation is achieved by a combination of such methods. And it's important to get the foundation of segmentation right. So you can't just have higher layer controls without having lower layer segmentation working. So just like this house with a weak segmentation, weak foundation, if you build a network with higher layer controls, then it's a weak system. And this translates to, due to many different attacks which can happen in such a scenario. I won't go into detail for all of them, but essentially an attacker, if he's in the same, let's say, broadcast domain as the device he's trying to attack, then essentially he bypasses router ACLs, firewalls, and gets to the end device pretty quickly. So he can also observe things like broadcast traffic, multicast traffic, link local traffic, anything, if he's on the same broadcast domain. And finally, even if the attacker wants to carry out, let's say, ARP poisoning or any other low-level attack, then it's pretty much a done deal. So with this in mind, let's take into account a case study of a healthcare network segmentation. It was interesting that it was mentioned in the introduction that healthcare networks was something that ISE have encountered to have problems with. And healthcare environments are kind of unique in that they have a lot of sensitive devices and data, which are usually high value targets for attackers, right? And hospitals have adopted IoT in a big way. So everything from the bed that this patient sleeps on to the X-ray machine which is used in the medical cards, everything is on the network. And finally, other characteristic is that many of these medical equipment still run old versions of Windows and other vulnerable software firmware. So with our data set of Forescout device cloud, we have collected over 4 million endpoints worth of network metadata from over 250 large deployments of Forescout, using which we can do some segmentation analysis. So for each of this device, we can identify the type of the device which is connecting to this network. The device may be an X-ray machine, a printer, a smartphone, or whatever. We are able to fingerprint what each of these devices are, and we can also identify the layer 2 network segment that the device is connecting to, right? We'll use this in our future slides. So first, we ask the question, are healthcare networks actually trying to segment the network better than the non-healthcare counterparts? So the non-healthcare may be something like an educational institution, a retail environment, and so on. So it's kind of good to see from this graph that, in fact, 40% of the healthcare environments we have in our data set have over 100 VLANs. So that's a good thing, compared to only 10% of the non-healthcare verticals who have over 100 VLANs. So this means that overall, yes, there are more segments in the healthcare environments, but is that good enough? We'll see later. So the other characteristic we found is that in healthcare environments, administrators often tend to create vendor-specific segments. So if there are particular vendors that the hospital buys from. So for instance, Philips or GE Healthcare, there will be separate segments dedicated for those vendors. So that's another good thing that we would say. But again, it's limited, dependent on the number of devices in these segments and the types of devices. It may need further granular segmentation. So let's take a look at what an actual VLAN in a real hospital network looks like. So what you see here in the figure is an instance of such a VLAN. So there are different sorts of equipment. They may be healthcare devices like blood glucose monitors, infusion pumps, and so on. And in the same segment, there are other non-healthcare IoT, something like surveillance cameras and things like that, in addition to traditional IT like computers, printers, or mobile devices. You may think this VLAN looks a little bit weird because it has a bunch of different types of devices. But in fact, for a majority of instances, we see that this device mix is common. In fact, it's over 90% of VLANs have a mix of healthcare and IT devices, and about 60% have a mix of healthcare and other IoT. So this is the norm, not the exception. And what's the problem with having such a device mix, right? So we know that many of these IoT are inherently vulnerable. They may have default credentials or other vulnerabilities. So in this example, we see an instance where a patient monitor has a default login. And in the same segment, there are other critical healthcare equipment like infusion pumps and blood glucose monitors and medical cards and so on in the same segment as this vulnerable machine, right? So the presence of this vulnerable machine introduces risk to this entire VLAN, and it changes the security state of the VLAN, and that's an important thing to know. And as it was alluded to earlier, So there are instances, real instances from hospitals we have observed where there is one VLAN per hospital floor or one VLAN per location, and this is really dangerous. So this means that any device on a particular VLAN, so let's say you're on a hospital floor and you're connecting your X-ray machine and let's say your computer or smartphone to the same network, you can reach the X-ray machine through your smartphone. That's not really a good thing to happen. And what we observed is that these situations occur where the networks have been inherited from some previous IT security teams. And yeah, basically it's a lateral movement bonanza. And there is also other issues. For instance, if you buy a new Cisco switch, we have what's called as a default VLAN on the Cisco switch, where all the switch ports on most of these switches are default connected to VLAN 1. So all the devices on VLAN 1 will be able to talk to each other. And it's recommended to never leave devices on VLAN 1 for security reasons, specifically so that if an attacker does end up on VLAN 1, he has nowhere to go. He can't move laterally. So that's the idea. And additionally, you shouldn't set VLAN 1 as the native VLAN because the attacker can do VLAN hopping or delete the whole VLAN database, and other bad things can happen. So the question is, how are healthcare environments doing in this VLAN 1, right? So on the figure on the left, each blue dot represents a healthcare environment, which we have in the data set. In the y-axis, you have the percentage of devices found on the default VLAN, and the x-axis, you see the unique device count of each of these environments, right? So what you see here is that many organizations are trying to minimize the default VLAN usage, but really surprisingly, there are a bunch of dots here for which the number of devices on these default VLANs are at least a quarter of the entire device population in those environments, right? If you see the order of magnitude, it's in the order of thousands of devices on the default VLAN, and that's really concerning. This is a fail. So what is on the default VLAN? So in healthcare environments, you see critical equipment like patient monitors, X-ray machines, pneumatic tube systems, so on. And it doesn't stop there. It also is a problem in non-healthcare environments. You see point-of-sale devices, IP cameras, and so on. And again, what are these guys thinking, right? So why are people making all these bad segmentation decisions? So what we see is that organizations often don't have a comprehensive segmentation strategy. And in fact, a Gartner report says that less than 1% of enterprises have implemented a virtual segmentation strategy in 2019. So the other reason is people don't know what's connecting to their network. So there are so many devices in the order of hundreds of thousands that administrators find it hard to actually know at all instance of time what's on the network and what's not. And there's a lack of understanding of the device context. So for instance, if an IP camera is on the network, is this IP camera involved in surveillance, or is it something used in a video conference room, right, or a meeting room? So this device context is important to set the conditions for which what traffic is allowed from the device to where, right? So this context determines segmentation, and administrators don't have access to such understanding. And in some cases, it may be that there is a trade-off between security and convenience. So maybe, having a flat network is easy to maintain, but is it the right config? And as I said earlier, there are some instances where there are legacy networks inherited from maybe an acquisition or another team. And in a healthcare environment, let's say there are real patients using patient monitors and X-ray machines, and you suddenly want to change the segmentation, and you don't want to break the patient care because of what you're doing. So that will introduce some hesitation for administrators to fix the problem. And there are equipment which can't be patched. So hospitals don't keep buying the latest X-ray machine, like the latest iPhone. So these are bought like once in a decade, and they're run sometimes really old versions of software which may not even be supported anymore. And finally, they may ask the question that we have such a high diversity of IoT in our environment that how will I deal with the segment explosion if I do create these segments, right? So these things are happening as we speak. So is there light at the end of the tunnel? And what are some guidelines? So we recommend that segmentation should be intentional. So whenever a segment is being designed, you should take into consideration the IoT device context and purpose. So you can infer this context based on the traffic patterns and also the device type. And the other thing is we shouldn't wait for these issues to occur from vulnerable IoT. So you should be proactively looking for vulnerable IoT and think of segmentation as a dynamic process, which will change according to the security status of the IoT device. And we should also avoid having these higher layer controls without getting the foundational basics right. And this is another problem we have observed. And finally, we should try to use software-defined approaches for segmentation, which will be able to deal with the scale of thousands of devices and device types. And finally, if you're a healthcare organization, there are some recommendations by NIST you can follow. NIST recommends a zone-based security approach. And in the figure here, you see that there are different VLANs being created for different purposes. So there may be a separate VLAN for biomedical engineering versus another VLAN for clinical services. And each of these VLANs are access controlled, and which segment can talk to the rest of the segments. So there is strict control between these segments. And there are some glimmers of hope. We see some instances of VLANs in production who are trying to better segment the medical devices from the guest VLAN. So for instance, in the guest VLAN, you may see things that people connect to in the lobby of the hospital, something like smartphones, tablets, e-readers, which is completely different from the medical segments, which may have glucose monitors, infusion pumps, and so on, right? This is good. So the question is, what did we learn from all this? So is it enough to perfectly patch an IoT device? So the answer is no. We need to ask what the security state is of the device neighbors. So this is not talked about enough. Everybody focuses on the vulnerabilities in the IoT device, but nobody thinks of what network environment it's actually in, right? And we should also limit what the device can talk to, who the device can talk to, and understand why it's talking to that endpoint at the other end. And we should ask, is the device in the right segment based on its role? If it's a medical device, it should be on a medical segment, and so on, right? The other thing to understand is that IoT security issues can be amplified by poor segmentation decisions. So even the presence of one weakly secured device can affect the risk status of the entire segment it lives on, and even more. And so it's important to act proactively and get an understanding of the situation in your network and be dynamic about segmentation. And as an enterprise, you will need a comprehensive strategy for segmenting your network. So we see from our results that many enterprises are trying, but we still definitely have a long way to go. And VLANs won't solve everything. So we need higher layer controls as well, and we need to keep the traffic from the device, which is going to the intended destination, not somewhere else. And we have talked about the zone-based security approach recommendations. And if you're doing a zero trust kind of strategy, do include the non-user devices, something like IoT in your network as well in that plan. And finally, you should move away from the illusions of security. Just because you have a bunch of security vendors in your environment already, that may give you a false sense of security that you should move away from. And you should get the basics right in order to ensure you're moving in the right direction. And AI is not always the answer. So network segmentation, let's do it, guys. that's my talk. Thank you. And you can reach me on Twitter, and also I'll be happy to answer questions in the Discord server. Thank you.
We think about IoT Village as a movement. These devices are being adopted so rapidly that security is not effectively being baked into the development and deployment of those solutions. That puts consumers at risk, that puts businesses at risk, that puts governments at risk. And what we're trying to do is to galvanize a community around solving that problem.
Every time somebody hears IoT, they immediately think, I don't want this in my house. But as time goes by, that choice of having something in your house or not is not really there.
You can walk in the village, you won't feel like you're asking a dumb question, and you'll still walk away learning something no matter what your skill level is or knowledge.
IoT Village provides an opportunity for people to experience security in a very tangible, very real way.
So what ends up happening is, I can kill Lisa right now. She's being smothered. She's flatlining, patient monitor's going nuts, she's dead. What's going on at the nurse's station? She's fine. What I'm doing right now is we are replaying recorded data of a healthy patient. So this patient monitor is something you'd see in every hospital room in America probably. The IoT Village seeks to raise awareness of IoT security. We want consumers to be able to make informed decisions, and we want manufacturers to improve their security.
So we put a lot of work into the security on the Bird 2, and we wanted to put it in front of the DEF CON community and see what people were able to do with it. We've learned stuff about our tech that we didn't previously know, and from my perspective, that's phenomenal because we have a really talented team internally, but when we can be educated by people external to the company, it's a big, big win.
We really want to show that we very much welcome the work that security researchers do, and even though we work in a world, the medical device world, that's not as accessible to the people that work in this space, we really value the input that researchers have. We want to show that we love for them to work with us on medical devices and what they can find in it.
Security is a mission-critical part of being a pioneer. And by participating in this, they're able to address some of the challenges that are introduced through innovation.
Building a contest to challenge hackers, at the world's biggest hacker conference, if these guys didn't know what they were doing, this room would be empty.
So IoT Village is awesome. Unfortunately, like a lot of hackers work in these small groups, they don't really share a lot of information because they kind of want to monetize or capitalize off of the information that they have. So being here in IoT Village gives us an opportunity to talk to a bunch of other hackers that we wouldn't normally talk to and share information and kind of like come together as one.
I think it is the best thing since sliced bread, personally. This year we're here at DEF CON helping run a hands-on lab, IoT Hacking 101. How do we get people involved with this? Because it might be intimidating, right? Walking up into a big CTF at a big conference. The idea is that we handhold them all the way through from the basics of firmware analysis right through to discovering a bug and popping a device or two.
I just connected over Netcat. There was nothing fancy, no authentication, anything like that. And this number here is your authentication token. It's a serial number on the device. That's what they're using for authentication. So what we're doing is that we're showing people how we find vulnerabilities in embedded devices. Specifically, I've been targeting NAS devices, and I've been showing how we find vulnerabilities, develop an exploit for it, and exploit it from the attacker's perspective.
IoT Village is the face of IoT security worldwide. They're probably the most preeminent brand when it comes to dealing with IoT security. We have expertise, they have expertise, and we feel that it's more than just a sponsorship, it's more of a partnership in which we share stuff with each other. The visibility that you get from all of these conferences is an amazing thing.
It's only going to get more and more relevant, and the devices are only going to get more and more prevalent. And so I think it's just a great interactive, hands-on experience for people to come and get immersed.
We know that these security challenges that are inherent within connected devices, they're not going away on their own. We're able to make these challenges come alive, to become real, to be tangible. And when we do that, We enable people to participate in being part of the solution.